Okay, calculus class. I think we probably need a couple of more examples from 3.1. It's kind of a challenging section, and 3.2 really builds from 3.1. So I'm going to give you these two examples that I've already written down on the slide. And we're going to take a look at these two additional examples for those of you that need a little bit of help. So just to review real quick, 3.1 talks about the first derivative test. Okay, so everything we do in this section is revolving around the first derivative test. And the first derivative test says if you take the first derivative and you set it equal to 0, you find critical values, and then you can determine if those critical values are maximums and minimums, okay, by using the first derivative test. So starting out, let's look at this very first example. So if I take a look at number 1, f of x equals x cubed minus 12x. And hopefully by now, if you're watching this video, you know you need to take the first derivative. The derivative of x cubed is 3x squared. The derivative of negative 12x is just negative 12. And then you take that first derivative and you set him equal to 0. And this one's quadratic, so you could factor it, but I realize, hey, this one's easy to solve. We'll just add 12. And we get 3x squared equals 12. Just using our algebra skills, we divide by 3. We get x squared equals 4. We take the square root of both sides. We get x equals, don't you say 2, you know good and well it's a positive and negative 2. So we have two critical values. X equals 2 is a critical value, and x equals negative 2 is also, these two are my critical values, which means those two values could possibly be a maximum or a minimum. And so we're going to use the first derivative test to figure it out. So if I draw a number line, we all know that negative 2 comes before positive 2, okay? So we need to test interval 1, interval 2, and interval 3, okay? So if I take a look and I go do that chart that I showed you in the first column or in the first video, the first row in my chart is the interval. The second row in my chart that I like to organize is the test value. The third is the what happens when I plug it into f prime of x, the first derivative. And then the last column or row is what the heck does it mean? Okay, so let's go back up here to this little picture that I drew. This first interval right here in pink, that is negative infinity to negative 2. The second interval that I'm looking at, and I'll draw a line to really organize this for you guys, is clearly right here, which is negative 2 to positive 2. And the last interval I'm looking at right here is a positive 2 to infinity. Okay? And so what is a number between negative infinity and 2 right here? Well, negative 3 is over there, so I'm going to plug in a negative 3. What number is in between negative 2 and 2? Well, 0 is in between those two numbers. And then what is a number between 2 and positive infinity? Well, 3 is. And you may say, okay, so what are we going to do? We're going to take these test values that you just determined and plug them into the first derivative. So if I rewrite the first derivative for you, gang, the first derivative, let me roll up, was 3x squared minus 12. Okay, that was the first derivative, if I'm not mistaken, yeah. And so we're going to plug in negative 3. So if I plug in negative 3, I get 3 times negative 3 squared minus 12. Well, negative 3 squared is 9. 9 times 3 is 27, gang. And when you subtract these two numbers, you get 15. I'll say it again. I don't care that the number is 15. I care that the number is positive. Okay, so it is a positive number. Do it again. So f prime of 0 now, gang, will be 3 times 0 squared minus 12. Well, that's simply 0 minus 12, which is negative 12. Again, that means it is negative. Okay? And then last but not least, f prime of 3 will be 3 times 3 squared minus 12. which again is 9 times 3, 27, minus 12, which is 15. Again, I don't care that it's 15, I care that it's positive. Because now, what the heck does this mean? If the first derivative is positive, then f is increasing. And if the first derivative is negative, then f is decreasing. And if the first derivative is positive, then f is increasing. So take a look at those. Remember, the first critical value was negative 2. I'm sorry, look at there. I didn't even put my negative sign. So the first critical value was negative 2. Okay, so take a look at negative 2. At negative 2, you went from increasing to decreasing. So we literally changed from increasing to decreasing, which means we were going up and now we're going down. So if we're going up and then going down right here, negative 2, x equals negative 2 is clearly, I got confused for a second, guys. X equals negative 2 is clearly a maximum. Okay. And now let's look at the other one. Let's take a look at our next critical value. Our next critical value was positive 2. So take a look at positive 2 to positive 2. Take a look what happened there. I went from, let's get another color out so you can really tell. I went from decreasing to increasing. So take a look here. If I'm going from decreasing to increasing, guys, I clearly have a minimum. So x equals 2 is a minimum. And like I made a big deal earlier, minimums and maximums are not x values. Minimums and max is our ordered pairs, so we need to find a corresponding y. So if I go back and plug f of negative 2 and f of positive 2, I can find my y values. So the original function, if I'm not mistaken, was x cubed. Oh, the original function was x cubed minus 12x. So it'll be negative 2 cubed minus 12 times negative 2, which is a negative 8, plus a 24, which is a 16. So the first ordered pair is negative 2, 16. That is the maximum. And then if you plug in a positive 2 cubed minus 12 times 2, that is 8 minus 24, which is a negative 16, which means 2 negative 16 was my minimum. Okay, so there is an example. And so I know on my math lab it talks about intervals of increasing and intervals of decreasing. And that's why if I come back to the beauty of this chart that I showed you, you can clearly see the interval that I'm increasing is negative infinity to negative 2 and 2 to infinity. And the interval that I'm decreasing is negative 2 to 2 because it tells you right here I'm decreasing. So the chart may seem extra to some of you, but the chart helps you get through the entire problem. Okay, so there is example 1 that I told you I'd work. And so now let me go to black and let's do example 2. It was 3x to the 4th minus 8x cubed. Okay, let me go down here because you know I can't remember stuff. Number 2, g of x was 3x to the 4th minus, I think it was 8x cubed. Let me roll back. 8x cubed it was, plus 6x squared. So let's do another example. Take the first derivative. Equals 12x cubed, that's derivative, minus 24x squared, okay, plus 12x. That is the derivative. And now I'm going to take that first derivative and set them equal to 0. So hopefully you realize we need to pull out a GCF, and the GCF is 12x. So if you divide every term by 12x, you get x squared minus 2x plus 1. And so you need to continue to factor. So 12x Factor, factor, factor. X times x is x squared. -1 times -1 is a +1, and -1 plus a -1 is a -2, so I have factored correctly. I now take all three factors and set them equal to 0. Divide by 12, x equals 0. Add 1, x equals 1. Add 1, x equals 1. So technically we have 3 critical values, but we have 2 distinct critical values. So my critical values are x equals 0 and x equals 1 are my critical values. Which means, again, they are possibly maxes and minimums. Okay? So let's go to our number line. If I draw my number line, we have 0 and we have 1. Okay, so we need to look at interval 1, interval 2, and interval 3. Okay, so let's go make our chart like we do. So I've got interval in the first column, test value in the second, plugging it into the first derivative, and then what the heck does it mean? And so my first interval is -infinity to 0. Okay, right here. My second interval right here is 0 to 1. And my third interval here is 1 to infinity. What's the number in between -infinity and 0? -1 is in there. There is no integer in between 0 and 1, so you're going to have to pick a decimal, heaven forbid. I'm going to plug in 0.5. And then what's the number between 1 and infinity? 2. And where are we plugging these numbers into? We're plugging them into the first derivative. And the first derivative, if I go back up, was 12x cubed minus 24x squared plus 12x. Okay. However, okay, I'm going to show you a shortcut here. When we factored it, it was 12x times x minus 1 times x minus 1. And so when you take your test values and plug into the first derivative right here, you can plug into the unfactored form or you can plug into the factored form. We've been plugging into the unfactored form every time I plug into the original derivative. Okay. But it's actually easier to plug into the factored form. Let me show you. So if I take the first derivative and I plug in -1, so it'll be 12 times -1 times -1 minus 1 times -1 minus 1. Again, I took right here and I plugged into the factored form. 12 times -1 is a -12. -1 minus 1 is -2. -1 minus 1 is -2. Like I've told you earlier, I don't care what the number is. I care if it's negative or positive. So a negative times a negative is a positive. But then if you times it by another negative, a negative times a negative times a negative, guys, is a negative. So that means the first one is negative. If I go through and I plug in 0.5, 12 times 0.5, and then 0.5 minus 1 times 0.5 minus 1. 12 times 0.5 is 6. 0.5 minus 1 is -0.5. 0.5 minus 1 is -0.5. Okay? A negative times a negative is a positive, and a positive times 6 is still positive. Again, I don't care what positive number is. I just know if I multiply number 1 times number 2 times number 3, I get out a positive. Okay? So do it one more time. F derivative, or the first derivative, and we're plugging in 2. So we have 12 times 2 times 2 minus 1 times 2 minus 1. 12 times 2 is 24. 2 minus 1 is 1. 2 minus 1 is 1. If you multiply 24 times 1 times 1, you get 24, but I don't care that it's 24. I care that it is positive. Okay, so hopefully by now you know if the derivative is negative, f is decreasing. And if the derivative is positive, f is increasing. And if the derivative is still positive, f is still increasing. Okay, so take a look at your critical values. Your first critical value was 0. At 0, you were decreasing and now you are increasing. So you were decreasing and now you are increasing. So we clearly have a minimum. So x equals 0 is a minimum. If I look at my next critical value, 1. At 1, however, though, guys, if you take a look at 1, at 1, you were increasing and you continue to increase. So we're increasing. So we're increasing and we're still increasing. So we don't have a minimum nor a maximum. So x equals 1 is not a min nor a max. And so now the last thing is to figure out the corresponding y value that goes with this. Okay, so f of x, again, if I roll back up, was 3x to the 4th minus 8x cubed plus 6x squared. And if you go plug in 0, some of you can already see it. You're going to get 0, 0, 0. Which means when you plug in a 0, you get out a 0. So the minimum is 0, 0 is my minimum. Okay. So again, if you go back up to your chart, here is your interval of increasing. Here is your interval of increasing. Here is your interval of decreasing. And we've already talked about there is minimums and no maximums. Okay. So there's 2 more examples. Hope that helps.